meet up a bit next week at least?
Yeah. Hopefully.
Get back to any of you golf or tennis players, or?
Yeah, I am.
Yeah, nice to be able to get back to that. But okay, so everybody able to see my screen okay?
Yeah.
So we were doing differentiation from first principles, which is following the formula, 4 steps each time. And remember, when you're doing that, you're getting the rate of change of the function, or you're also getting the slope of the tangent of the function. So I stuck up a video earlier this morning on the solutions, but does anybody want me to run through any of those in particular again before we move on?
Yeah, miss, can you go to the second part of the second question? I'm in the third one.
Question 5, part 2, is it?
No, question 2, part 3.
Question 2, part 3, sorry. Okay, so 3x squared minus 4x minus 6. You able to see that okay?
Yeah.
So first thing to do is write down your f of x. 3x squared minus 4x minus 6. And our formula is the limit as h tends to 0, f of x plus h minus f of x or h. And the most you're going to be asked to do, the highest power of x you're going to have to deal with is an x squared. So what you really want to make sure that you know how to multiply out two numbers, a binomial squared, which we've done a few times. So the first thing is write down f of x plus h. So wherever you see an x, you're going to put in x plus h. Okay, so that becomes x plus h squared, and use brackets. Okay, just like if you were subbing in a number, use brackets, put in the number. This time we're putting in x plus h. Now you need to multiply that out. And just be careful when you have a number in front of something, or when you, especially when you have a negative, you need to be very careful multiplying it out. So in this, I know it's going to be x squared plus 2xh plus h squared, because it's the first squared, twice the first by the second, and then the last squared. Everybody remember that okay?
Yeah.
Okay, good. You need to know that because you're just doing it so often. You know, you need to have it at the tip of your tongue. So x squared, then that times 3 is 3x squared. 2xh times 3 is 6xh. And h squared times 3 is h squared. Then we have negative 4x and negative 4 by h. And then you have the minus 6. That's step 1. Step 2 is subtract f of x. So I write f of x underneath so that these 3 terms will line up with their corresponding terms here, which makes the subtraction much easier. Okay, so I'm just spreading it out so that they're exactly under their corresponding term in f of x plus h. So that then when you do the subtraction, f of x plus h is this line minus this line. The 3x squareds are gone. So you have 6xh plus h squared. The x's are gone. The minus 4h, and the number is gone. And everything here has a h in it. Okay, that will always be the case as well. Step 3 then is to divide by h. So this divided by h means it's just 6x. H squared divided by h is just h. And 4h divided by h is just 4. And then the last thing is to get the limit to 0, which means wherever there's a h, we sub in a 0 of that whole thing. And I would write this out every time. There's no h here, so that just stays the way it is. It's independent of h. It doesn't care about h. This one, h is going to 0, so when I sub in 0 here, that's gone. And then this doesn't depend. It's independent of h. So that's your final answer. Is that okay?
Yeah.
Any other ones to go through?
Can you go through 6 part 2?
Yeah. So 6 part 2 is basically, so in the first part, I'm not going to go through the first part because it's basically like this again.
Yeah. I knew how to do the first part. I didn't know how to do the second.
So 2x squared minus 3x minus 2 Sorry, I'm just writing it out again. So if you like, f prime of x is when you differentiate it and you get 4x minus 3. Okay, that's when you differentiate it. And that means it's the slope of the tangent at any point. And remember that slope will change depending on what x is. So in part 1, we have the 0.37. So x is equal to 3. So it's f prime or f dash of 3. So wherever there's an x, we sub in 3. And that's 12 minus 3 is 9. And that is the slope of the tangent, because that's what that is defined as. When we're differentiating, we're getting the slope of the tangent, or the rate of change. So that's our m. So the tangent is a line, and to get the equation of a line, we use y minus y1 is equal to m times x minus x1. So m is our slope, which we've just worked out for this particular tangent at the 0.37. That's what the slope of the tangent is going to be. It's going to be 9. If I'm at a different point, I'm going to have a different slope. So this excuse me. I've just, at this 3.7, sorry, just swallowed something the wrong way. 3.7, that's our x1, y1 that we're going to use in the formula. To get the equation of any line, you either need the slope and a point, or you need 2 points. So we have the slope and we have a point. So we can go back here and sub that in. y1 is 7, m we worked out was 9, and then x1 is 3. So whenever you're doing an equation, first thing is get rid of brackets. So 9x minus 27, and then bring it all over to the same side. You have 9x minus y and negative 27. When we bring this over, that's plus 7. That would be negative 20, and that's all equal to 0. So remember, when you're asked to find the equation of a tangent, it's the equation of a line. So you always need slope and a point. And how you get the slope is differentiate. So is that okay?
Yeah.
Yeah.
And question 7, okay? Or do you want me to run through that?
Yeah, run through that.
Yeah, that was a bit weird.
Yeah. The only weird thing with this is that we're using different letters. So instead of f and x, we've got a and or. Okay? So a is equal to pi or squared. And they ask it a little differently. They say, what's the rate of change of a with respect to or? And that means what's the derivative of a with respect to or? Now, what we can do is, because a is a function, it depends on or, we can write it as a of or, okay, is equal to pi or squared. And they want us to find a dash or a prime or, which is going to be, so instead of f of x plus h, I've got a instead of f. I have x instead of or. So it's a of or plus h minus a of or over h. And the limit, sorry, of h tends to 0. Okay?
Yeah.
So my a of or plus h, I'm just going to put in or plus h instead of or. So that's pi times or plus h squared. So that's pi or squared. 2 or h by pi is 2 pi or h. Okay, so that's the first by the last by 2 by pi. And then the h squared by pi is pi h squared. Subtract my a of or. So I write that down underneath its corresponding term. Do the subtraction. That's, so you just have 2 pi or h plus pi h squared. And divide by h. So you've got 2 pi or plus pi h. And then you get the limit as h tends to 0. So anything with a h in it is gone now. Or h, and that's just equal to 2 pi or, because that's gone to 0 then. Is that okay? So the whole thing, like a lot of the problems that people have with maths is when you have something like this, a word question, and suddenly you don't have x's and y's anymore. Freak out. Try not to worry about it. Just say which part corresponds to the y and which part corresponds to the x. And then it's just the same steps, okay? So there's only one formula that we need for this chapter. It's just a case of revising it to suit the question. So what we're going to do now is go on to differentiation by rule, which means instead of having to do all these 4 steps every time, we're going to notice the pattern of what happens and use a rule that will allow us to differentiate. And the good news is that most of these rules are all in the tables. There is a page on calculus, page 25 in the tables. And we have all our different types of functions with powers of x. This is all the different types of functions, and this is their derivative. So instead of having to go through all those steps of f of x plus h minus f of x, etc., we're just going to go through these rules, okay? So if everybody's looking at page 274, which I have up on the screen there, is that okay?
Yeah.
And we'll have noticed, well, you mightn't have noticed, but if we went through, if just f of x was equal to x squared, and we went through the whole thing from first principles, we'd notice that dy dx is equal to 2x, okay, if we did our whole, what we've just been doing. And if it was 4x squared, then we get dy dx is 8x. If it was x cubed, it would take a little longer to work out, but we would eventually see that dy dx would end up being 3x squared. And what they kind of realized by looking at these patterns was there's a similar thing happening each time. So basically, when you have your x to a power, okay, instead of having to go through the whole f of x plus h, what you do is you bring the power down in front, and then the new power goes down by 1. Okay, so I'm just going to give you a few examples. So if we had x squared, okay, if that's f of x, then f dash x, I bring the power down in front, so that's 2x, and then this power goes down by 1, so it's just x to the power of 1, which is just 2x. If I had x to the power of 5, then f prime x, or dy dx, bring the 5 down in front, and then 5 minus 1 is 4, and that's all you have to do for your power. Is that okay so far?
Yeah.
So you could go through it all from work it all out in first principles, and we don't want to be multiplying out x plus h to the power of 5. You know, you'd be using your binomial. Let's use this rule now in future, okay? Now, if there's a number in front of it, that just gets multiplied by the power. So say I had f of x is equal to 4x cubed, okay? I bring down my power to the front, so that's going to be 3 in front. So 3 fours is 12. Does that make sense? And then the power goes down by 1. So it's 12x squared. If I had 6x to the power of 7, bring down the 7. 6 is 42. And then reduce the power by 1, becomes x to the power of 6. Is everybody okay on what you're doing for that?
Yeah.
And that's the first rule in the tables. If you have x to the power of n, and that's the only rule we're going to be worrying about for a while, and just kind of combinations if we're adding and subtracting with that. You bring down the power, so the n comes down in front, and then you change, the new power goes down by 1. So that's your first rule there in the tables, okay? And you can see that in the book, and they've written it with an A in front as well. Sorry, I'm just trying to put the screen again. The A in front there, see differentiation by rule. The first one is the one we were just looking at. The second is if there's a number in front of it, then the A multiplied. That's what NA is in number 2 there. And in words, what that's saying is to differentiate a term that just has a power of x, you multiply the coefficient by the power and then change the power, reduce it by 1. Okay, and they've given a few examples there. So 3x squared, 2 3s is 6, and then the new power is 1. 3 7s is 21, and the new power of 3 minus 1 is 2. Everybody see what I'm working on here? 5x, the power is 1. So 1 5 is 5, then the new power would be 0. And anything to the power of 0 is 1. So that would be just 5. Is that okay with people? So 5x You see where that's coming from?
Yeah.
Yeah.
The power is 1, so we do 5 ones is 5. The new power is 1 minus 1 is 0. And then x to the power 0 is just 1. So it's 5 times 1 is 5. Then the last one, 6x to the 4. 6 fours is 24. Take away 1, you're left with 3. Okay, so then let me see. Yeah, if you have, yeah, we'll do the constant one first. Right, okay, so with a constant, okay, what happens is, so say I have y is equal to 4, sorry, that's a constant, okay? Say I want to derive that. So what's the rate of change of y with respect to x? Now, common sense, as x is changing, is y changing? If y is equal to 4, what kind of graph is that? What does that graph look like? Y is equal to 4. What will that graph look like? Come on, guys. What's a graph of y equal to 4? I go up to where y is equal to 4. Is it going to be a line, a parabola, a circle, a wave? What's it going to look like?
Straight.
A straight line. What kind of straight line? What's its slope?
Horizontal. Horizontal.
Horizontal. Okay. And what is the slope of a horizontal line?
0.
0. Okay. And when we're getting dy dx, remember we're getting the slope, or we're getting the rate of change. How is y changing? Is x changing? Now, as x is changing here, is y changing? As I move along the x-axis, is y
No.
changing? No, it's staying stuck at 4. So if y is constant, obviously its rate of change is going to be 0 because it's not changing. So just using common sense, we can see that the rate of change of a constant is equal to 0. Okay, because a constant is unchanging, therefore does not have a rate of change. Now, if we want to work that out mathematically using our rule, y is equal to 4. 4 times 1, and remember 1 would be x to the power of 0. Does that make sense? Everybody
Yeah.
see, because x to the power of 0 is 1. So if I want to use my rule, I can write that. I mean, this is the long way around, but just to show you that it works for the rule as well. So now if I'm doing dy dx, I bring the 0 down, and I've got 0 times 4 is just 0, and it doesn't really matter what the power of x is, that's just going to be 0. So that's your next rule. The derivative of a constant is going to be 0. Is that okay?
Yeah.
So that kind of makes sense. Now, the next rule is just very straightforward as well. If you're adding and subtracting, so if you have a combination of different powers of x, then you just do each little bit separately. So the 2x squared, I'd use the rule for, and then the 5x, I'd use the rule for that, and then I would just add the results. Okay, so the derivative of a sum or a difference of two different functions. So if the function is more than one term, we just differentiate each in turn, one after the other. Okay, so don't worry about this u and v just yet. But basically, y is, so example 1 there is 2x, 5x. So you 2x squared is one function and 5x is another function. So I could get the derivative of each of those, and then I just add them together. Okay, so what you're doing there is just doing each bit in turn. So let me just go through them. It's pretty straightforward. So if you have y is equal to 2x squared plus 5x, then dy dx. So for the 2x squared, I just bring the 2 down. So I have 2 2's is 4. Write down the x, and then my new power would be 2 minus 1, which is 1. So I don't bother writing down the 1. And then with the 5x, my power is 1. So 5 times 1 is 5. My new power is 1 minus 1 is 0. So that's just gone. And my answer is 4x plus 5. If we have y is equal to 6x cubed minus 3x squared plus 4, okay, then f dash of x, or y prime dy dx, bring down the 3, you've got 3 sixes is 18, and the new power is 1 less, which is 2. Write down the minus, then you've 2 3s is 6, new power is 1, which we don't need to write, and the derivative of a constant is 0. So it's gone. Okay. So if you notice, this is going down 3 2 1, and then the derivative is going 2 1 0. See that the power is reduced by 1 for each part.
Yeah.
Is that okay? And then just underneath that, this is important because our rule only applies to if the function is written as x to the power of. So if it's not written like that, we have to change it around. So if we had something like equal to 1 over x squared, I want to write that as x to the power of something. So then I go to my page in the tables where I have my powers. We look at the rules of that if you can't remember them. And 1 over something to a power means I can change the power to a negative. Is that okay with everyone? Do you remember this rule of indices?
Yeah.
Okay. So 1 over x squared is the same as x to the negative 2. So if your function is not in the form of x to the power of something, you need to change it by using the rules of indices, which are on page 21 in the tables. And now you go ahead and you do your dy dx. So I bring the minus. So when your whole power includes the sign, so that's going to be negative 2 x, and minus 2 minus 1 is minus 3 would be your new power. So it's the same rule, it's just be careful because it's negative. So you bring the power down and then you reduce the power by 1. Is that okay?
Yeah.
And very quickly through example 1, we have 6x cubed minus 3x squared plus 4x. Now, it might say find the derivative of, it might say derive, it might say find the slope of the tangent, it might say find the rate of change. All of those are asking the same thing, just use the rule. Okay? So bring the 3 down, 3 sixes is 18, new power has gone down by 1. Bring the 2 down, got 2 3s is 6, new power has gone down by 1. Bring the power down, that's just 4, and the new power is 0. So that's f prime of x, or that's the derivative, or that's the derived function. And then find, it says hence find f prime of 2. So wherever there was an x up, there is now a 2. So this is the slope of the tangent at the point where x is equal to 2. And that would be 18 times 2 squared minus 6 times 2 plus 4, which is 18, 4. Anyway, it works out at 64. Okay, when you plug it into your calculator. So the slope of the tangent where x is equal to 2 of this curve, the slope at that point would be 64. So it's changing pretty quickly at that point. Is that okay?
How come you can't just slot in the 2 straight away?
Back here?
Yeah.
Because that would give you the y value. So let me just show you on a graph. It would give you the value of f of x, but you don't want the value of the function, you want the value of the slope of the function. So we're not looking for the y value, we're looking for how fast the function is changing. So
Okay.
the function here, 6 cubed minus 3x squared plus 4x. Okay, there's my function. Okay, and you can see it's quite steep. Now, if I plot the derivative, so at the point where x is equal to 2, yeah, if I go along here, x is equal to 2. Now, see the way my x's and y values are changing. I have to go quite far up. I'm going to zoom out. If x is equal to 2, y is equal to probably 43, I guess. Okay, 44 maybe. I can't get it exactly. Yes, probably 44. Okay, you see that?
Yeah.
Now, if I plot the derivative, which is 18 x, sorry, not 18 squared, 18x, 18x squared minus 6x. That's the blue line there. So the derivative, the slope is changing all the time. That blue line represents the slope of the function. So what it's saying to me is at the point 2, the slope is actually point 2, the slope would be equal to 64. So it's, you're looking at a different function. The derivative is the slope, and the slope is changing as you move along the function, okay? So because this original one was a cubic function, the derivative is actually a quadratic function. With the quadratic and x squared, my derivative would be a straight line. So it changes all the time. Find dy dx for each of the following. So I'm just going on to example 2, and I'm going to do part 2 of example 2 just, okay? Because that's another thing, another example of where we need to change our format. So example 2 at the bottom of page 276. Neither of these is in the form of x to a power. So you have to change them. Now root x is x to the power of what? Square root of x means x to the power of? So remember, root is that's on this page of the powers and roots as well. It's x to the power of 1/2. Okay? So when you have a root and you want to change to a power, okay, you put the root is the bottom of a fraction, okay? And when it's just square root, we don't bother writing the 2 here. If it's cube root or fourth root or fifth root, we have a number here. If there's no number here, you assume it's a 2. There's no number here, so we're saying it's square root, so that's x to the power of 1/2. And then this is minus 4 times, and remember, underneath means x to the power of minus 2. So you have to be very strong on your rules of powers and roots. They are all on page 21 in the tables. Okay, so have that page to hand when you're doing these. So I've rewritten y into a form where it's x to the power of something and another x to the power of something. Everyone okay with that?
Yep.
Okay. So now I can apply my rules. So dy dx, take my power 1/2, bring it down. So I've got 1/2 x, and then my new power is 1/2 minus 1 minus 1/2. And if you're confused, you just use the calculator. Then I have, move on to this one. I've got -4, bring down my power would be times -2, which would be plus 8, x to the power of, and then -2, take away 1 is -3. And that's your derivative. Now, you should really give your answer in the form that you started with. So we need to turn this one back to roots, and we need this to turn this one back to fractions. So the minus here tells me it's 1/2 times x to the power of 1/2. So that gets rid of the minus. The minus here tells me it's 8/x to the power of 3. Is that okay with everyone?
Yeah.
And then the 1/2 here tells me it's a root. So it's 1/2 times, and I'm just focusing on the x, root x, and the 8/x cubed, and that's your final answer. So as I say, you need to be strong with your powers and roots and negative powers and how to change back and forth between them. Okay? Is that all okay?
Yeah.
And then the last example is very like what we were just doing. Find the slope of the tangent to the curve. The slope is dy dx. So we differentiate. We have y is equal to 3x squared plus 4x minus 5. So dy dx, bring down my 2 times 3 is 6x, and then this will be plus 4. at the point 1, 2. So at 1, 2, x is equal to 1. So this would be, if I sub the 1 in here, I'd get 2. But I don't want the 2, I want the dy dx value. I don't want the y value, I want the slope. So that's 6 times 1 plus 4, that's equal to 10. So that's equal to the slope of the tangent. So now when I want the equation of the tangent, I have y minus y1 is equal to m times x minus x1. y1 is, x1, y1 is this point here. So I have y minus 2 is equal to 10 times x minus 1, which is 10x minus 10. So you've got 10x minus y minus 8 equals 0. And that's the equation of the tangent. Example 4 we'll leave for now. I think that's enough for one day. So for homework, let's do the odd parts of questions. So questions 1 and 2, do parts 1, 3, and 5. Same for questions. So 1, 2, and 4. And then 5 and 6, okay? And this is, you'll see there's a lot of questions to do on this. We'll go through some together in class tomorrow. You can work them out that class if you're getting stuck. Because this is calculus, it comes up over and over again, and this is really the fundamental rule. So you want to do a lot of practice in this and get very strong in it before we move on, okay? So if you want to have a crack at a few of those now while we're still online, and then finish them for homework. I'll just start putting them in my classroom now. Any questions?
No.
It looks like we'll be doing exams the week after next, I think. And I'll get back to you as soon as I can with what topics we're covering in the exam and so on. I'm not sure yet what way we'll set it, but I'll let you know. Hopefully in the next day or two, I'll let you know what's going to be on it.
Will
Okay.
we be doing calculus for the exams?
What? Sorry, Aaron?
Will we be doing this? Will we be doing this chapter in exams?
Yes. Whether we get to the end of the chapter or not, but we certainly do a bit of it. Yeah, it's quite a big chapter, so we'll see how we get on. But certainly we want some. I would like to get this chapter finished because I think that would be a good thing to get done before the end of the year. So I would like to see more homework being submitted as well. Okay, I only got 4 of last night's handed in. You need to be doing better than that, lads. If you're not practicing, you're not learning. And check your answers as you're going along. Make sure you're getting the hang of it. Everyone doing okay?
Yeah.
Did anyone watch the video I put up for the solutions to the last one? Was that helpful at all? Or
Yeah.
I'll try and get one done for this as well. But, you know, use them as something to refer to if you get stuck rather than kind of just copying them down, okay? You want to try and be able to do it yourselves. Okay? All right, I'll let you go, so lads, and I say I'll try and get up a video of that and let me know if you have any questions, okay?
Thank you.
Take care.
Thank
All
you.
right, bye.